Yes, good morning, my dear friends, and welcome to physics online classes. Okay, students, maybe in the last class we are discussing about the applications of semiconductor diode. In the last class, we are discussing about the applications of your PN junction diode, and as we know already, the most important application is diode. That is nothing but your rectifier. The most important thing applications your diode is nothing but rectifier. And maybe today you are going for the lecture number 10. You are going for the lecture number 10. It means as you know already, the important property of diode. It conducts only one direction, or it is an unidirectional device, or the current conducted only one direction, or it works only for gas. Because this property, it is used as a rectifier. Because of the property of diode, it conducts only one direction, it is used as a rectifier. And as you know already, the rectifier nothing but it is a device or circuit. They will convert AC into pulsating DC. The process of converting AC into pulsating DC, that is nothing but your rectification. And the device that converts the AC into pulsating DC, that is nothing but rectifier. Look here, you have already studied about the two important types of rectifier. One is called your half-wave rectifier. One is called your half-wave rectifier. Half-wave rectifier. Half-wave rectifier. Rectifier. And the second one is about full wave rectifier. Full wave rectifier. Wave rectifier. Look here, already studied discussed already in the last class. So it is an important question for 5 marks. They will ask explain the construction and working of half wave rectifier or full wave rectifier. The thing is that in the name indicates meaning in half wave rectifier, they will only convert one half cycle. No doubt you are converting AC into pulsate DC, but here in half wave rectifier it will convert only one half the cycle. It will convert only one half cycle. It means half wave, nothing but it will convert AC into DC only one half the half cycle. That is called half wave rectifier. And the important thing here you are using only one diode, and for the positive half cycle that diode conducts because it is forward bias, you will get the output. But in the negative half cycle, that diode is not conducting because it is in reverse bias. That's why you are not getting any output across the output. That is about in a simple way of half-wave rectifier. And we are using the step-down transformer because we want AC. The AC goes by step-down transformer. And finally, you are using about the full-wave rectifier. Full-wave rectifier nothing but no doubt it is a type of rectifier. In this type of rectifier, they will convert both half cycle. It positive half cycle as well as negative half cycle, they will convert into AC into pulsate DC. The important thing here we are using the center type transformer. Here we are using the center type transformer, and also in place of one diode we are using the two diodes. The important thing in the full wave rectifier, we are using the two diodes and a center type transformer. Now you are using center type transformer to divide the voltage. To divide the voltage, we are using the center transformer and we are using the two diodes. As we know, in the positive cycle, the D1 conducts because that is forward bias, we will get the output across the RA. In the same time, in the positive cycle, D2 is not conducting because that is in the reverse bias. It means you are not getting the output across the D2 is not conducting. Only you get the output because of the D1 is conducting. That happens in the positive cycle. What about negative cycle? No doubt. Negative cycle, D1 is reverse bias, but D2 is forward bias, it's not conducting. We will get the output because of the D2. This is about, I said in brief about half-wave rectifier and full-wave rectifier. And also I said you are having so many drawbacks in the half-wave rectifier because so much loss of the signal is there because you are converting only one half cycle. That's why efficiency also very less, the 41% or 40.8%, and ripple factor also very more, that is 1.21. And compared to full-wave rectifier, they have more efficiency, 80.6 or 81%. And also the efficiency are very The efficiency about 81% and return factor very less, that is about 0.48. This is about the study in the last class. Now we go for another so important types of studying about the another small concept, that is about optoelectronic devices. Optoelectronic devices. What are optoelectronic devices? It is also called as the study about the special purpose diode. We are studying about today's class about the special purpose diodes, or also called as optoelectronic devices. Now we look for what is optoelectronic devices. No doubt, here the important thing, you are combining the electronic and optics. You are combining the electronic optics. It means what? No doubt, your electrons are moving. They are moving because of the light. Your electrons are moving. Current. You are having a current. That current is because of the light. That's what is called optoelectronic. Opto nothing but light. Electron nothing but you are moving of the electrons. You are studying the moving of electrons. The moving of electrons, that is because of the light. Electrons are moving, no doubt. That electrons moving because of the light. That's what is called optoelectronic devices. It means, no doubt, it is a branch of physics or branch of electronics. Here we can combine the optics and electronics. We can combine the optics and electronics. It means the current conduction because of the moving of electrons. That is because of the light. That's what is called optoelectronic devices. Or it is also called as, you are studying about the special purpose diodes. You are studying about the special purpose diodes. Actually, studying about the three important special purpose diodes. One is called photodiode. Another is called LED. It is nothing but LED. It is also called light-emitting diode, and also studying about the solar cell. We go for in detail about the construction, working, and also characteristics of your photodiode and LED. And if possible, you can go for also solar cell. It means why these are called special purpose diodes, or why these are called optoelectronic devices. It means, in brief, no doubt you are using a diode here. You are using the diode. Why the diode is a special purpose? Because as you already studied about the normal diode, it conducts only for bias, and that the diode is because of the you are applying the voltage, then current goes through the diode. But in photodiode, the current is because of the falling of the light on the junction. It means here the current depends upon the light. It means, in simple way, in photodiode, the light energy converted into the electrical energy. In the photodiode, the light energy converted into the electrical energy. But in LED, the reverse of photodiode. In LED, what happens? In LED, the electrical energy converted into the light energy. In LED, the electric energy converted into the light energy. In the same way for solar energy also, by the light energy converted into the electric energy. This is about why these are called the special purpose, because here your photodiodes conduct in reverse bias, but LED conducts in forward bias. Once again, in the solar cell, you are not applying any biasing voltage. That's why these are called special purpose diodes. They are used for special purpose. They are meant for special important their characteristics, their function. That's why they are called special purpose diodes. Now we go for the important about the construction and working about photodiode. We go for that. Photodiode. We go for the photodiode. Here, as usual, no doubt you have studied already about the normal diode or PN diode. No doubt the photodiode, it is also special purpose semiconductor device, or it is special purpose semiconductor PN junction diode. It is a special purpose PN junction diode. What is photodiode? It is a special purpose PN junction diode. The important thing, it is a special purpose PN junction diode. And important, it conducts in reverse bias. The important thing, it is a special purpose PN junction diode. It conducts in reverse bias. And important thing, it works on the principle of inner photoelectric effect. It means the important thing, no doubt, the symbol of your photodiode, it is similar to the normal diode, but there will be an arrow. They are arrow like that. This is the symbol of your plus minus or P or N, correct? No. It means the photodiode, no doubt, it is basically special purpose PN junction diode. It conducts in the reverse bias, and it is the working principle of photodiode is about the inner photoelectric effect. It is also called as photovoltaic device. And this is about the information about the what is photodiode. Now, how it works or construction of your photodiode. We go for the construction of the photodiode. Look here, as usual, it contains a P layer grown on in N layer by the method of diffusion. A P layer grown on in A P layer is grown on N layer by the method of diffusion. And look here, as usual, it contains an P-type semiconductor right here, an N-type semiconductor. And here, as usual, we know in the P-type semiconductor having the holes are metallic carriers. Wherein the holes are metallic carriers in the P-type, as you know already. And also having the electrons also they are the magnetic carriers. No doubt you are having holes are very more, but still you are having the electrons also they are the magnetic carriers. And here having the depletion layer that contains here negative ions. As we know, the depletion layer is a layer that forms because of the positive and negative ions. In this layer you are not having any electrons or holes, that is immovable ions. That contains immovable ions. And look here, your varying potential or electric field, VP. And here having the electrons are more, electrons are more here. But you are having also the holes are also there. The holes are the magnetic carriers. This is about the simple structure of your photodiode. The important thing, actually you can look here. Actually your photodiode that consists of in the junction here, you are having it is composed of a transparent window. Here they are having a transparent window. Here it is contains a transparent window. It is having it contains a transparent window. Why we want here transparent window? Because light fall on that transparent window, or also light will enter into the junction. In between the B and N or in the junction, what you are using? You are using transparent window. Why you are using transparent window? Because light fall on in your transparent window, and that light will move towards the junction. Because that I said, the photodiode. Why it is a photodiode? Because it depends the working of photodiode, that depends upon the light falling on that junction, or some photon of light energy that fall on the PN junction. Why it is called photodiode? Because the light fall on that junction, or some photon of energy light fall on the junction, that is what is called photodiode. To observe that light, you are using a transfer window. In the junction here you are using a transfer window. It means because of that the light fall on that junction. Now we look for the working of this photodiode. As I said, it conducts in the reverse bias. It conducts in the apply beam to the negative. And how it conducts? We go for that. Look here, as usual, as I said here having a transfer window, and you are applying the light energy. You are applying the light energy or light incident on the photodiode, or light strikes on the photodiode, or some photon of energy will be fall on that transfer window. Because that is transparent, that light waves they move towards the junction, or they move towards the depression layer. It means here you are applying some light energy, some photon of energy. This energy should be more than your energy gap. You are applying the energy, a photon of energy, that is equal to E is equal to H nu. E is equal to H nu. Here H nothing but the Planck constant, and nu nothing but the frequency of the radiation. It means you are applying the light energy, you are applying the some photon of energy, you are applying the incident, you are having some, you are incident some light energy. That energy should be more than the Eg. It means what you can write? The E is greater than Eg. Then only we can here you are applying the light energy. That energy should be more than the Eg. That energy should be more than is Eg. You are applying the energy. That energy should be more than your band gap energy. Then only you can break the covalent bonds. And actually here what happens? You are applying the some light energy. You are applying the light energy that should be more than the Eg. Now you are applying the energy. You are applying the energy that should be more than the Eg. It means we can write about the energy for on the junction that should be more than your Eg. As you know already, Eg for your the band gap energy for the silicon, that is 0.7, and for your silicon it is for the it is for germanium, and for silicon that is 1.1. It means actually you are applying your incident light, or whenever the light falls on your junction, that light energy, the photon energy, that should be more than the energy gap. That should be more than the energy gap. In that time what happens? Because of you are applying high energy, you are applying the high photon energy, that what happens here, they will be incidenting on your depression layer. No doubt, in the depression layer you are not having an electron, you are not having a hole, but they are called immovable ions, or you can say that contains atoms. That contains an atom. And as you know, whenever for example, consider this atom. This is silicon atom. And as usual, in the outer orbit, you are having the 4 valence electrons. In the depression layer, you are having the atoms, because you are considering the silicon diode. In the silicon diode, what happens? You are having the 4 valence electrons are in the outer orbit. Whenever your light rays are incident on the atom, then what happens? Because of high energy of light energy, or because of light having the high energy, the photon energy, this electron will come outside. Because it comes outside, it becomes the free electron. It becomes the free electron. It means whenever you apply the high energy to the atom, or you apply some light energy to the atom, then what happens? This electron will come outside, because you are applying high energy, or you are breaking the covalent bond. Whenever you break the covalent bond, as you know already, the electron hole come in pairs. No doubt, you get the hole. Whenever you are breaking the covalent bond, how you are breaking the covalent bond? By applying the light energy. If you are applying light energy, because of light energy, what happens? You are breaking the covalent bond. No doubt, in the depression layer, atoms are there. That atoms, because of this light energy, they break the covalent bond, they will come outside, and we get electron and hole come in pairs. And what happens? This electron, for example, here, you are having some electron here, and you are having the hole here. What happens to the electron hole? No doubt, this electron and hole, because of this electric field here, in the depression has the electric field. Because this electric field, what happens? The hole will move towards the p side and electron will move towards the n side. Because of the electric field in the depression layer, the hole is moved towards the p side and the electron will move towards the n side. Because actually they want to recombine. Because of the electric field, the hole move towards the p side and electron move towards the n side. For what I am saying? Because of the light energy, you are applying some light energy, you are applying some photon of energy, you are incidentting the light on the transparent window. That what happens? That light will enter into the depression layer. In the depression layer, the atoms are there. That atoms, you are applying some energy. Then what happens? Because of high energy, the atoms, what happens? They will break the covalent bond, and the electron will come outside. In the same time, electron come outside. That atom acts as a hole, and the electron come outside. Or whenever you break in the covalent bond, what happens? The electron hole come in pairs. The electron hole come in pairs. And here, how much you are incident the light, that much of electron holes and electron holes are generated. You are incident so many more energy. You are applying more light energy. Then you are applying the more number of electrons or holes are generated. It means here the electron holes are generated. That depends upon the incident light. If you are incident more light, then more number of electrons holes are generated. If you are incident more light, then more number of electrons holes are generated. And this holes and electron they want to recombine, but because of electric field here, because of high electric field here, that electric field will move the holes towards the p side and the electron move towards the n side. Because of electric field, what happens? The holes will move towards the p side and the electron move towards the n side. Because as you know already, here the electrons will be attracted to positive ions and holes will be attracted to negative ions. That's why they move towards the p side and also they move towards the n side. It means how many number of light incident on the junction, that much number of your electrons and hole space are generated. That electron hole space they will move towards the p side and holes move towards the p side and electron move towards the n side. And if you connect here a load, if you connect here load, you can connect a load, or you can connect here in microampere to measure the current. And if you are applying the reverse bias, no doubt, before falling the light in the reverse bias, because of the reverse bias we are having very small current. As you know, in the reverse bias you are having very small current. That current is because of magnetic carriers. That current is very small. And now you are falling the light on the junction. Because of light energy, what happens? We are having the more number of electrons, holes are generated. And that electrons, holes, as you know, the holes will move towards the negative side and electron move towards the positive side. Each movement of electron hole, they will generate the current. That current is nothing but the photocurrent. That current is nothing but the photocurrent. It means you are applying the reverse bias. Because of reverse bias, no doubt, the current is because of magnetic carriers. The current is because of the temperature. An important thing, this is because of the applied voltage. And also you are applying the light incidenting on the depression layer. Because of incidenting light, you are having more number of electron holes are generated. That electron holes, because of the you are applying reverse bias, the holes will move towards the negative side and electron move towards the positive side, and they will generate a current. That current is nothing but the photocurrent. It means in the reverse bias, we are having the current. That current depends upon the magnetic current. It means if you are not applying any quota of energy, you are having very small current. And if you apply some light of energy, if you apply the more incident of the light, then what happens? More number of electrons also generated, you get the more current in the reverse bias, or you get the more photo current. It means you get the photo current in the initial it is maybe the 10 milliamperes or something, 10 microamperes something. And whenever you are inserting more light on the depression layer, then what happens? This will be increases. It may be 20 microamperes or it may be 30 microamperes like that. It means the photocurrent that depends upon the incident light. The photocurrent is depends upon the incident light. How many number of your incident in the light, or how many number of light is incidenting on the depression layer or junction, will get the more photocurrent. It means the photocurrent that depends upon the incidenting light. How much your intensity of light is falling on that junction, how much the intensity of the light falling on the junction, that depends upon photocurrent. As the intensity is more, the photocurrent is also more. It means in overall what I am saying here, whenever you are applying the incident light, or you are applying the photon of energy, because photon of energy in the depression atoms, they will break because you are applying the high energy. Because at high energy the electron come outside, and also whenever electron come outside, that atom becomes the hole, or you are breaking the covalent bonds. And whenever you break the covalent bonds, as you know already, the holes and then it come in pairs, generating pairs. That hole, because of electric field, that hole move towards the p side and the electron will move towards the n side. And here what happens, because you are applying reverse bias, this hole will move towards the negative side and electron will move towards the positive side. This movement of electron hole, nothing but the photocurrent. What is photocurrent? The movement of electron and movement of hole. The electrons are moving towards the positive side and holes move towards the negative side. This movement of hole and electron, nothing but the photocurrent. This is about in simple way of your photocurrent. Yes, what is dark current? Another important thing, what is nothing but the dark current? What is called your dark current? No doubt, if you are not applying any light energy, then you are having very small current. That current is in terms of microamperes, or that current is only magnetic current. That current is nothing but the dark current. Without applying the light energy, it is your light energy, not the absence of light energy. Then what happens? You are having very small current. That current is because of the reverse bias. That current is because of magnetic areas. That current is nothing but dark current. Dark current nothing but you are not applying any light energy. You are not applying any incident light. That is nothing but dark current. And important thing here, how many number of rays are incidenting on the junction, that much you are having the photocurrent. It means the photocurrent depends upon the incident light. The photocurrent depends upon the incident light. And I will go for the VI characteristics. I will go for the VI characteristics. What is the VI characteristics of the photodiode? VI characteristics. The VI characteristics of photodiode. Look here, as usual, it conducts in the reverse bias, and here you are having like that this is nothing but your mu A, this is nothing but your VR, this is nothing but your this may be I1, I1, I2, I3, like that. The important thing is the I1, can write about I1 is more than I1 is more than I2, I2 is more than I3. It means, as I said here, you are drawing the graph in the reverse bias, because photodiode conduct in the reverse bias, and as I said in the beginning, you are having very small current. That is nothing but that current is because of the saturation current. That is also called as reverse saturation current. As we know, in the reverse bias diode, the current is nothing but reverse saturation current. That is called reverse saturation current. And this current is very small because the incident light is very less. As the incident light increases, the current also increases. The photocurrent also increases. Because I1 is greater than I2, I2 is greater than I3. It means as you are applying the more light fall on the junction, you are having the more photocurrent. This is about the simple construction and working of a photodiode. It means, keep it in mind, first important thing, the photodiode, it conducts reverse bias, and the photodiode, nothing but it depends upon the incident light. It depends upon the falling of the light on the junction. And important thing, it works on the principle of photoelectric effect, inner photoelectric effect. And as usual, as I said, it contains a transfer window. In this window, you are incidenting the light, or your light strike on that window. That light will move towards the junction or move towards the depression layer. And in the depression layer, as we know, there are some atoms. They are neutral atoms. They are not having any electron, they are not having any holes. Just atom, you are having the semiconductor atom, or they are having silicon atoms. If you are applying the light energy, if you are applying some photon of energy, because of that energy, what happens? Here the electron come outside because of energy. And also I said, if you are applying the photon energy, that energy should be more than the Eg. That energy should be more than the Eg. You are applying energy, that should be more than the Eg. You are applying this should be more than the Eg. And then only you can break the correct one. And important thing, you will get the more number of electron holes are generated. And because of the electric field here, that electric field or that varying potential, this hole, whatever generated whole electron, the hole will move towards the p side and electron move towards the n side. Actually, the electron hole they want to recombine because high electric field, the hole will move towards the p side and electron move towards the n side. It means because of the reverse bias, what happens? This hole will move towards the negative side and electron move towards the positive side. You will get the current, and that current we can measure by using the load or by using the micrometer. We can measure that current. And as we know, in the reverse bias, the current is only because of the microamperes. Current is because of microamperes. And important thing, the photocurrent, that depends upon the how much number of intensity of the falling of light. That depends upon the intensity of falling of the light. If the more intensity of light, if the more intensity of falling of light, you get the more photocurrent. And as usual, another thing I said about if you draw the VI characteristics, and in the beginning, as I said here, in the beginning, with the very less number of photons are incidenting, you get very less current. And as the number of photons are increasing, the number of incident lights are increasing, the reverse current also increases. It means, so I am saying here, and also important thing, what is dark current? There was one more question. What is dark current? If the light is not falling on the diode or junction, where I have very small current, that current because of the magnetic arrays, that current nothing but dark current. It means whenever the light falls on the junction or depression layer, you get the more current. This is about in brief about your photodiode. And important thing, what are the applications of photodiode? It is used as a counter. It is used as a counter. Can count the how many times the things are happening. It is used as a counter. It is also used as an optocoupler. It is also used in optical communication. It is also used in the optical communication. This is about the importance about the photodiode and construction and working, and also I said about the VI characteristics of your photodiode. Keep it in mind. The photodiode, it is a reverse biased diode. And important thing, why it is called photodiode? Because whenever the photon of energy incident on the depression layer, then it is not conducting. And important thing, the photodiode, it is nothing but the light energy is converting to electrical energy. The light energy converting to the electrical energy. It conducts the reverse bias, and it is working on the principle of inner photoelectric effect. And how you have to incident light, or your some of the light falling on that junction or depression, that light should be more than the energy gap. There should be more than energy gap. Then only you can break the covalent bonds or get the electron holes will be generated in base. And because of the electric field here, that electron move towards the n side and move towards the p side, or here apply the reverse bias. Because the reverse bias also, the electron move towards the positive side and hole move towards the negative side. This movement of electron hole nothing but the photocurrent. And if you apply some load, here you can measure the photocurrent, or by using the your micrometer we can measure the current. This is about the photocurrent, and also I said about the photodiode. Now we go for another small, that is about your LED. We go for the LED. What is called LED and conception and working of the LED. We go for the conception and working of the LED. It is called light-emitting diode. Light-emitting diode. Light-emitting diode. In short form LED. In short form LED. Light-emitting diode. No doubt, it is also special purpose PN junction diode. The light-emitting diode. LED in the short form LED, light emitting diode. It is also an special purpose PM junction diode. And important thing, it works in Photodiode. It works in Photodiode. And here is reverse of the photodiode. Here what happens? The electrical energy converting to the light energy. Here the electrical energy. The electrical energy is converting into light energy. It means the important thing, the LED, it is a special purpose PN junction diode. It works in the forward bias, and here what happens is the LED, the electrical energy is converted into the light energy. And important thing, this is the symbol of your LED. The symbol of LED is nothing but like that. The arrow is away from the junction. That is in the photodiode, the arrow is moved up, it is moved towards the junction, it is away from the junction. This is about the symbol of your LED. No doubt, LED is a special purpose PN junction diode. It works on Photodiode, and it is electric energy converting into the light energy. This is the book in brief about your LED. Now we can go for the construction and working of the LED. How the LED works. No doubt, as I said, it is also an PN junction diode. No doubt, here also a P layer. A P layer is grown on an N layer by the method of diffusion. A P layer is grown on the N layer by the method of diffusion. And as usual, here we can have the P type, N type, and here having then depression layer. And another important is heavily doped as compared to the normal diode is heavily doped. And here having the holes are magnetic areas, as you know already, and also electrons are the magnetic areas here. No doubt we are having electrons also there. And here also electrons are more. And also we are having holes are also magnetic areas. It means less number of holes are there as compared to the electrons. And here you are applying, yes, it is written apply the power bias to the diode. It conducts in power bias. Look here. Here what happens? Look here. Here, as I said, here also it is having a transfer window. because the light should come outside. The light should come outside. In the photodiode, the light will go inside, but here light will go outside. That's why we are using a transparent window. It also contains a transparent window. It also contains a transparent window. By that window, the light will go outside. And look here how it works. Look here, as usual. As I said, it is heavily doped. And also you are applying the powder bias. When you apply the powder bias, what happens? As you know already, because the powder bias, what happens? The depression layer reduces. The depression layer reduces. An important thing, you are applying the powder bias, then what happens? And because the powder bias, these holes, they move towards the N side, and electron, they move towards the P side. Because of powder bias and the depression layer reduces, and important thing, the holes will move towards the N side and electron move towards the P side. Because of the powder bias, what happens? The holes, they move towards the N side and electrons, they move towards the P side. They move towards the P side. Because of the powder bias, the holes, they move towards the N side, the electron, they move towards the P side. Here what happens? Look here, as we know already, here you are applying the high powder bias. You are applying the powder bias. Because it what happens? This hole, they move towards the N side, and this hole is majority carrier in the P side, and here electron minority carrier. But in the N side, what happens? The electrons are the majority carriers. As you know, the electrons are majority carriers. It means electron very more here. But the holes are minority carriers. Actually, what happens? Whenever the hole, they move towards the N side, what they will do? They will recombine with the minority carrier. This hole, they move towards the N side. This actually small hole is a minority carrier. This hole will recombine with the majority carrier electron. This hole, majority carrier in the P side, but this hole is minority carrier in the N side. This hole will recombine with the electron in the N side, majority carrier in the N side. At the same time, the electron is majority carrier in the N side. This electron will move towards the P side. Here holes are the majority carriers. This electron majority carrier is in the P side. This electron will recombine with the hole. And actually, the hole and electron recombine. The hole and electron recombine. They will generate the energy, they will give the energy, they will give the energy that energy is more than the energy gap, more than the Eg. It means whenever the electron and hole recombine, they will be neutralized, they will disappear. What happens? They will generate, they will give the energy, especially in the LED. Whenever the electron hole recombine, they will emit the light. They radiate the light. It means whenever the electron hole recombine, no doubt, in your normal junction, they will give the heat in terms of heat. But in LED, whenever the electron hole recombine, they will give the energy. That energy is nothing but in terms of light. They will give the energy in terms of photon. Actually, we know according to the energy band diagram, we can study the LED means here you are having the conduction band, here I have the valence band, as you know, valence band, conduction band, and here the holes are carrying the electrons here also there. Since we have the electrons only from countries, valence electrons. No doubt, you are applying the powder gas. Because the powder gas, what happens? This electron, they move towards the conduction band, and in the same time, what happens? you are applying energy, that energy should be more than the Eg. That energy should be more than the Eg, and as we know that energy will be 1.1 for silicon and 0.7 for germanium. And as usual, if you are using the electron, the valence cell they move towards the conduction band, and they will move towards the conduction band. You have to apply the energy that should be more than 1.1 or 1.7. If this electron, once again this energy not sufficient, that electron will come back and they will recover the hole. And whenever the electron will recover the hole, they will also generate energy. That energy in terms of light. It means in the LED you are not using silicon or germanium. Why you are not using silicon or germanium? Because you are using the energy E is equal to h nu. You are using this relation. Important thing, if you want to light means you can write here also. If you want to connect this h is Planck constant, is constant. You take E is equal to, or you can write about F is equal to E by h. It means the frequency that depends upon the energy gap. The frequency of light that depends on energy gap. It means you have to use the energy gap. That should be energy gap should be more than 1.8 volt to the 3 electron volt. It means you have to use the semiconductor, that energy gap should be more than 1.8 to the 3 electron volt. Only that type of semiconductor will emit the whenever they recombine, they will give the light as a energy. No, you are not using silicon or germanium because their energy is less than 1.8, and that's why you are not using in the LED. To conserve energy, you are not using silicon or germanium because their energy gap is very less, 1.1 for silicon and 0.7 for germanium. You are not using silicon or silicon. What you are using? You are using gallium arsenide. You are using GaS, gallium arsenide, or you are using gallium phosphate, or you are using gallium nitrate. Like that, we are using the different types of semiconductors. And if you are using such type of semiconductor, the gallium arsenide, gallium phosphate, this energy, the energy gets more than 1.8 or 3 electrodes. Then this type of, you are using this type of semiconductors in the LED. Then if the electron will recombine, they will give the light in terms of energy. They will give the, whenever the electron will recombine, they will give the energy in terms of light. No doubt, here in the normal also the electron will recombine, they will give the energy, that is in terms of heat. But if you are using gallium arsenide, gallium phosphate, or you can write gallium arsenide phosphate, also you can write gallium arsenide phosphate. Like that, if you are using different types of gallium phosphate, gallium arsenide phosphate, like that, if you are using different types of semiconductors, then you can give the different colors of the LED. You may get red color, you can get the red color or green color or yellow color. You can get the different colors, that depends upon the what type of semiconductor you are using. The important thing, one thing important, keep in mind, you are using the semiconductor here, that should be the nearly about the 1.8 electron volt. No doubt, you are using the semiconductor, gallium arsenide, gallium phosphate, gallium arsenide phosphate, their energy gap is more than 1.8 electron volt, or it should be nearly 1.8 to the 3 electron volt. Because of such semiconductor you are using, then what happens? Whenever the electron will recombine, no doubt this valence electron, they move towards the conduction band, they will here also they will recombine, or this free electron, they lost the energy, they move towards the p side, they move towards the valence band, they here they will recombine, and this recombination of electron hole, they will give the energy in terms of photon of energy, or they will radiate the energy, that is in terms of light. It means here, like that, light emitting the light. Once again repeat, very simple. As you are applying the power bias to the heavily doped PN junction, no doubt it conducts in power bias and it heavily doped, Because of heavy load happens, the differential layer is also very less, and also because of the heavily doped and because gold bias, the differential layer reduces. And when the differential layer reduces, what happens? The hole they move towards the n side, and electron they move towards the p side. At the same time, what happens? The hole, whenever they move towards the n side, this hole that acts as a magnetic carrier here, and this electron they move towards p side that acts as a magnetic carrier here. It means this hole they move towards n side, they will recombine with the magnetic carrier, that is electron. This electron they will move here and they recombine with the hole as a magnetic carrier. It means whenever the hole and electron recombine, they will give the energy in terms of light, or they will radiate the energy in terms of light. And important thing, why they will radiate the energy in terms of light? Because you are applying the energy that should be more than the 1 part electron volt. You are using the semiconductor, their energy gap is more than 1 part electron volt. If their energy gap is more than 1 part electron volt, they will radiate the light, they will emit the light, and that's what is called light-emitting diode. Why it is called light-emitting diode? Because as you know already, or you can write also E is equal to H mu, and as usual E is equal to, in place of H is constant, you can write mu is equal to C by lambda. And the important thing, here C is, H is constant, C also constant, but your energy that depends upon the lambda. It means actually if you are applying the energy, if there should be more than 1 part electron volt or nearly 1 part electron volt, they will give the energy in terms of light. Especially it may be the red light, or it may be the green light, or it may be the yellow light. It means depending upon the energy gap, we can get the different types of light, and depending upon the wavelength, as you know, the wavelength is very more, and we get the red light. It means nearly about Eg, about 1.8 electron volt. We get the red light. That is because of gallium arsenide phosphate. If you use the gallium arsenide phosphate, we get the red light. Or if you use only the gallium arsenide, if you only gallium arsenide, they give the energy in terms of that is nothing but the infrared light. Infrared. This is not visible. This is not visible. That infrared LED. That is nothing but it is not visible light. Because it is less than 1.8. The energy gap is less than 1.8. They actually given 1.6 something. They given 1.6. That is invisible. That is called infrared LED. The gallium arsenide will give the energy. That is, you can't see that. That is called infrared LED. And if you are using the energy gap, if it is more than 1.8 electron volt, we can see the light in terms of red, green, or yellow, like that. It means what I am saying here. Important thing. Here you are not using the silicon or germanium. Why you are not using silicon or germanium? Because their energy gap is less than 1.1 or 0.7. If you are using the silicon or germanium, no doubt there also electron will recombine, but they will give the energy in terms of heat. But if you use the energy gap, it should be more than 1 part electron volt. It may be gallium arsenide, gallium phosphate. In that type, if the electron will recombine, they will give the energy in terms of light. They will give the energy in terms of light. The important thing is about you are not using the silicon or germanium, you are using the gallium compound semiconductor. Let's say about you are using the compound semiconductor. Maybe gallium arsenide, gallium phosphate, or gallium nitrate, like that you are using. The important thing, their energy gap should be more than 1 part electron volt to the 3 electron volt. Then only whenever we have said here, if you are applying the power bias, no doubt the holes they move towards the n side, electron they move towards the p side. In here the electron will recombine here also electron will recombine here. Whenever they recombine, they will give the energy in terms of light, or they will give their energy in terms of radiation. That is nothing but you are working of your LED. It means the LED emits the lights. When the LED emits the light, the important thing, whenever electron will recombine, they will emit the lights, they will produce the light, or they give the light. No doubt, this is about the importance about your LED. Now we go for the, as I said, it is similar to the normal diode. It is similar to the normal diode, the VI characteristics. We will go for the VI characteristics. We go for the VI characteristics. for the characteristics. That is nothing but it is similar to the normal diode, but important thing, like they are different. This is nothing but VF, this is nothing but IF. And here the important thing, you have to apply the knee voltage, that is nothing but 1.8. The knee voltage is very low. We are applying the knee voltage, that is about 1.8 electron volt. Right here, knee volt. Or you can write about here, the energy gap is 1.8 to the e to the 3 electron volt. It means as it is similar to the normal diode, but important thing, the energy gap or knee voltage should be more than 1.8 electron volt. And as usual, depending upon the energy gap, if the energy gap is more, that depends on red or blue, green, like that, they will emit the different lights. It means in overall, it is similar to the normal diode, but important thing, the energy gap is very more, or you are not using silicon or germanium because their energy gap is less than 1.1 or 0.7. No doubt, whenever the electron hole recombine, they also give the energy, that is in terms of heat. But if you are in the compound semiconductor, gallium arsenide, gallium phosphide, gallium nitride, they are also electron hole recombine. They will give the energy in terms of light or photon of energy. And depending upon the energy gap, the energy gap is very more, you can get the different colors of the LED. This is about in brief about your LED. And important thing, what are the applications? What are the applications of LED? No doubt, there are so many applications of LED. Nowadays, very more important is LED. It may be your, as you are using in calculators, as you are using in your LED, LCD TVs. Now, because they are using LCD TVs, nowadays they are using LED TV, and it is also used in your traffic control, traffic light. It is also there in your, especially in the burglar alarms. You are using burglar alarms, or you are using in your TV remote. In the TV remote also you are using the LEDs. These are the applications of your LED. They are using in the burglar alarms. They are using in remote control the TV. Also they use a screen for the TV or your mobile or your laptops, computer. It may be LED TVs or LED screens are nowadays become LED TVs. And another about the, it is also used for the 7-segment display and 16-segment display. It is also used in the 7-segment display. Or it is also called as 16-segment display. It is also used for the optical communication. The LED is also used for the optical communication. This is about the applications of your LED. The important thing, don't confuse the LED. It works in the photodiode. It is heavily doped PN junction diode. The important thing, you are not using your normal silicon or germanium. You are using the compound semiconductor. That energy gap is more than 1.8 electron volt per 3 electron volt. And whenever the electron hole recombine, they will give the energy in terms of light. That's what is called light-emitting diode. It emits the light whenever the electron will recombine. And also important thing, in the emitted light, that depends upon the applied voltage. As we are applying more voltage, we get the more light will emitted. If we are applying the more voltage, more power bias, they are having the more light will emitted. This is about in brief about your LED. The important thing in LED, the electrical energy is converted to the light energy. In the LED, the light energy, the electrical energy converting to the light energy. Important thing, you are using the semiconductor. Their energy should be more than 1 electron volt. Then only they, whenever the electron recombine, they will give the energy in terms of light. They will give the energy in terms of photon of energy. And depending upon the different types of, you are using the compound semiconductor, you get the different lights. And as you know, it may be red, it may be green, or it may be white, like the different colors also you can get from the LED. And important thing, keep it in mind, LED works for only for the forward bias. You should not apply the reverse bias for the LED. It may be turned in the reverse bias. It is not working in the reverse bias. And why you are giving more importance to the LED? Because it is having long life and it requires very less voltage, less power, and also important thing, it is having long life. It is switching actually very fast. It is switching actually very fast in terms of nanosecond. It is used as switch in nanosecond, can on and off. This is about the important advantages of your LED. And this is about the today's class. And don't confuse, the photodiode is a reverse bias. And important thing in the photodiode, it is a special purpose diode. The photodiode important thing is about the photodiode. The important thing, the light energy is converting to the electric energy. In the photodiode, the light energy converting to the electric energy. But in the LED, the electric energy is converting to the light energy. And photodiode is reverse bias, the LED is forward bias. The important thing in the photodiode, the current, the current depends upon the incident light. How much you are incident in the more light, you get the more photocurrent. But here the current that depends on the applied power voltage. This is about in brief about photodiode and LED. In the next class we go for only small thing remaining, that is about solar cell and remaining about the gates, logic gates. We will go for the next class. Thank you.